Welcome to another episode of A Junior, a Senior, and I. I'm extremely pleased with the guests we have with us today to discuss software teaming. But before we start discussing them, let's meet our guests. Woody, could you introduce yourself in 3 sentences or less, please?
Sure. Well, my name is Woody Zuhl, and I think of myself as a software developer, although I really haven't written any production code much in the last 10 years because I've mostly been helping people learn about working together as a team to do software development, which we used to call mob programming, but that I now call software teaming. Same idea.
Great. Thank you very much. What about you, Philippe?
So my name is Philippe. I'm the CTO of NodalView. I've been a software engineer for 15 years or so and a manager for 5 years. I'm a big believer in pair programming, but I've never done software teaming. So I'm really happy to be here and learn a lot.
Great. Thanks. Let's start with you, Philippe, then, who might have preconceived notions of what software teaming is. What is for you software teaming?
The way I imagine it is kind of pairing, but with more people. So I imagine someone behind the keyboard and then talking while writing about the problems currently being solved. I basically imagine that it's a pair programming session just with much more people, all of them maybe mentioning together and trying to get the attention. So this is the kind of problems I imagine, the kind of reason why I've never tried. But at the same time, I think it might be a bit less exhausting because pairing is extremely exhausting because you have to verbalize all the thought you have. So I imagine that if there's more people in the discussion, then it means you can take a rest sometimes, because if there's only 2 people speaking, none of them can take a rest.
I see. And Woody, what quote unquote really is software teaming?
So I think that you brought up some good and interesting things there. Maybe at the core of this is that all of the work that we do in creating software in a workplace, it's different if you're working on something you're writing for yourself. But when we're in a workplace, all the software we do that other people are going to use requires that we somehow interact with other people. So if that's true, we might as well get good at it. If we need to interact with others, then let's make those interactions as meaningful and useful and easy and productive and whatever we want to call it as we can make it. So when I first started working with other people doing software development, I had been working solo for about 15 years or so. And then in the end of the 1990s, people started talking about pair programming. And so at that point in my career, if somebody said, hey, here's something I heard about, then I want to learn about it. At first, maybe my way was I would hear something like that and say, that's crazy. You just sit alone and you program. That's how you do this. But, by this time in my life, say I was 45 years old or so, I thought, well, okay, if somebody's doing that, there's a reason. Let's figure it out. Let's see what they're doing. So the basic idea of pair programming is that we have twice the brain power, twice the experience, twice the background, twice the perspective on all the work that we're doing. Now, it may be exhausting and sometimes for some people, but I would say simply this. If we find it to be exhausting, we need to figure that out. We shouldn't just say, oh, well, this is exhausting because, whatever reason. We should be saying, okay, well, I don't want to be exhausted all the time. What I found with pair programming was that it actually made my day easier and less exhausting, more engaging and yet more relaxing, less stressful. So if others are finding it different than that, I would say, well, there's something we need to discover. What's the difference? So a part of that might be the person we're working with. Part of it might be how good we've become at working with other people. I can make tons of examples, but from my younger years, I tried to be a musician for a while, and I would play in bands and things like that. And sometimes somebody would call me up and say, hey, because I played the banjo mostly, say, our banjo picker isn't able to make it to this gig we have on Friday. Can you come and sit in? So in those days, I knew the genre, the type of music we were playing. I knew, I'd heard all the material that everybody was doing. And it's all similar enough that I could just come and join in with the band, play right along with them. They're not going to do anything I'm not already somehow familiar with. And it sounds as if I'm just a regular member of this band. They might not be able to do everything they would normally do, but you get the picture here. It's like if we're really good at joining the team, becoming capable really instantly without any practice with that group, then we have achieved a certain level of skill or capability. So this is part of it. In 2011, I started working with a team where we eventually, within a few months, started working full-time as a group with 5 or 6 of us at the computer all the time. And it just worked really, really well. We had been practicing being together and working together, doing what is known as a coding dojo. In this style of coding dojo, we would have one computer and the 5 or 6 people sitting in front of that computer. One person's at the keyboard. And we were learning techniques for making this easy to do so that we could all be paying attention to the same thing and working on it at the same time. So the skills that we needed to build for that include 3 or 4 important things. One of them is we have to be able to express our ideas somehow. And we need to be able to do it in such a way that they don't evaporate or just disappear. So if I say something, if we didn't capture it somehow, I might have to say it several times to restate what I'm trying to say. Well, if we have a way to capture it so that everybody can see what we're doing, it's the same thing. We're all thinking about the same thing. So a whiteboard is a real good way to do that. There are other ways as well that I could share. But you get the picture here. We need some techniques for doing this. Another technique is, or another thing we need to be good at, is following someone else's instructions. If somebody asks us, like, let's say I'm sitting at the computer, there was a guideline we used. I better start with that. And this works well for pair programming. This was a guideline from pair programming that I'd learned along the way. The idea is for a concept or an idea to go from someone's head into the code, it has to go through someone else's hands. This means if you have the idea, you give the keyboard to someone else. You're not the one typing it in. You don't go, oh, I know what to do, and you start typing it in.
That's interesting. Yes. You can never write your own idea.
Right.
It means like if you really believe in your idea, you actually have to convince someone, basically.
No, you don't need to convince someone. So this is part of the guideline of what we would follow by. If somebody says, oh, I know what to do, then someone else will take the keyboard and they will put the idea in as you guide them to put it in. Think of it like this. If you get into the taxi cab, you say to the taxi cab driver, please take us to the airport, right? You're not going to say, put your foot over the gas pedal and start pressing slowly down. Oh, now we're moving. Turn your right signal on. We're going to turn right in just a moment here. You're not giving them instructions at that level. You just say, here's my intent. Let's go to the airport. And the taxi cab driver kind of knows how to get to the airport. And if they start not going towards the airport that you mentioned, you say, oh, I meant I meant Heathrow, not Gatwick. And so they're going to find the airport that you're guiding them to. So there's 3 things there. One is the level of intent. If I were to say, for example, we're going to need a drop-down that contains a list of the regions so that a user can select their region. Well, the person at the keyboard might know how to put that in, but now the idea is heard by everybody on the team. It would be better if I put it on the whiteboard. So that's a technique of getting that idea out there. So it's kind of like this. We've learned to program by typing characters into a keyboard, but that's not programming. I mean, that's not creating the software. We just need to have a way to get our idea into something the computer can use. And before my time, they would do that with a punch card. Matter of fact, there were machines that used punch cards way before computers as we know them were invented. And so somebody along the way said, oh, we can use a textual way of writing these instructions into the computer. All we've done is we've removed the ability of the person thinking. We've removed the necessity for them to have their hands on the keyboard.
Yes, but what if they currently have their hands on the keyboard? And that, because you mentioned the guideline is that in order for your ID to go into the code, it has to go through someone else's hands.
Right.
So what if you currently have the keyboard? Because I think that in pair programming, there's a format which happens very often. It's probably the easiest format to understand is there's a mentor and there's the mentee, like 2 people with very different kind of experience. It happens a lot. It's definitely not the only way to do pair programming, but this is a way that everybody understands and usually accepts. Now, in those cases, at least in my experience, when I had the keyboard and I had an idea, I was basically verbalizing, explaining, oh, I have this idea. For the record, this is how I came to this idea. This is why I believe it's a good idea, blah, 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 blah. This is why it's a bit exhausting, because you cannot simply type your idea. You have to explain your idea. And usually this is where the value of pairing comes, because you explain your ideas, and while you explain it, you realize there's a slightly better idea to be had. So I believe there's a lot of value in explaining your ideas. We're not so far from rubber duck debugging at that point. But what you explain is that if you currently have the keyboard and you have an idea, you should basically give the keyboard to someone else.
Exactly.
Am I correct?
Yeah. So this has come to be known as strong pairing. So there are many styles of pairing. But if I was I worked at a place, it was in 2003, and I had been at this place for about a year and a half or 2 years, and I was probably the tech lead or the highest level skilled person in the firm, but we weren't allowed to do pair programming. And so I had gotten laid off because the company was having to get rid of some people. And so I needed to hand off my work to a very much junior person. So we sat down at the computer and I started saying, well, here's some of the things we need to know. And I was showing them the different parts of the project and the different classes and how they interacted. But I could tell real quickly that this was not going to move things along. So I said, how about you take the keyboard? Now, I wasn't inventing this. But I said, why don't you take the keyboard? They sat down at the keyboard then. And I said, well, here's one thing we need to look at. They struggled through finding it and looking at it. And then I said, here's how we would use this. And here's how we would use that. And this project I was handing off was a way to quickly spin up websites. This company was buying companies and rebranding their websites, and they needed to do this frequently. So that's what this project did. So, well, this junior person was one of the most junior people in the development department, was needed to get up to speed on this thing. So I just guided them through it. After 2 weeks of doing that, they pretty much knew everything I knew, but I hardly ever took the keyboard. So this was way before I learned the idea, which I had learned from Llewellyn and Falco, of for an idea to go from somebody's head into the computer, it must go through someone else's hands. But as soon as he said that, I recognized it as a pattern that I had worked by. So what this does, it allows us all to stay in the same cognitive space. We're sharing the context. And when we're in the same cognitive space, then everything that everybody's thinking about is related. And we're thinking about these things from different perspectives. So if the person's sitting at the keyboard, to me, it doesn't matter whether we're junior or senior. The junior person will have ideas that are just as good as the senior person's ideas. And so we need to be really careful not to think that this is the one person who knows, and this is the one person that's learning. And it's not really that way. This is the person who knows, and this is another person who knows some different stuff. And so when they get combined, we've created a bigger brain.
I wish I agreed with you, but I think it's not entirely true. It's a little bit dishonest, which is, of course, two people have valid ideas and junior people have fresh ideas, and there's value in that freshness.
Yes.
And experienced people have experience, and there's value in experience. So there's value in freshness, there's value in experience. If we take this to the next level, there's value in diversity, in a diverse team, people with different kind of ideas. But the value of experience sometimes is worth more than the value of freshness. Sometimes the value of freshness is worth more. So it's not similar. Like, depending on the context, I think the value can be different. And to be perfectly honest here, I think very often the value of experience is worth more than the value of freshness.
That may be true, but we actually found when we worked as a group, if we had something we wanted to accomplish, and somebody would say, oh, I know what we could try, and someone else says, oh, I have an idea to try, then we would always try both ideas. After a while, we started realizing if we try the more junior person's idea first, we will get more learning than if we try the more senior person's idea first. So we kind of made it a guideline for ourselves that we would try the more junior person's idea first. When we rush to a solution that we go, oh, I know what to do, and we use this existing way of doing something, we're actually reinforcing that we're not going to learn the new things that we need to be learning. And with software development, whatever we already know is already out of date.
When you say trying an idea, does doing a thought experiment, does it count? Because sometimes juniors have ideas. I think they need to be listened for starters, because they need to be reinforced in sharing their ideas, because it can be a bit frightening. But sometimes we can just make a thought experiment. Say, okay, let's imagine we do that idea, because it might be a good value. It might be a good idea. At this point, we don't know what happens when this context happens or that context happens. Like what happens when we reach 1,000 requests per day, because this is what we have, or what happens when these business partners try to use this idea. So if you were saying that you're always trying ideas, but it includes just talking a little bit about them, then I would agree with you. All ideas are worth being tried in that way, but not worth being like programmed.
Yeah, I would say that we will often talk about something longer than it would have taken to just try the thing. So sure, analyzing stuff can be good, but actually doing it in code is often a quick way to see what its reality is. And we can write tests that'll show us those things. I think that it's in the doing that we get the learning, and not the thinking about it or the talking about it. That's my own approach. That's my approach.
Can I give an example? Like, it's a bit absurd, but it could happen. Imagine someone very, very, very junior, and you're trying to do like a sign in page, whatever, and they suggest storing password in clear, right? Because it's faster. Like that's the abstract. Yeah, it would be lighter on the database, and it would help when debugging. Maybe they say, oh, when customers calls us and say, I forgot my password, we can just give it to them because we store them in clear. So this is the idea that they would suggest. As an experienced engineer, I have like probably 1,000 reasons why this is a bad idea, but you're saying we should try that idea. So how would you do that?
You just try it. I mean, you literally do it and say, look, let's do it and see what happens. And then we try the other idea too, and then we can compare them.
But it works. It works, like storing password in clear, it works.
Sure. And so then we can analyze what is the result of that. So here's the thing. We can question these things. And if we're going to say, well, this is what we need to do, and I would argue this, I think that that's an example that we would rarely see in real life. I'm thinking more real life coding examples would be, we have an algorithm we think we should use, someone else has an algorithm they think we can use. And we can use both. I've often seen people analyze a problem for hours or days before they start trying things. And my argument is we just try them. And we see things in 5 minutes that others would take hours to discover through talking about and analyzing.
Okay. So is it more something like there's a threshold? Like we talk about that idea maybe for 5 minutes. I mean, the threshold does not have to be 5 minutes. But we talk a little bit, and if after that threshold we still the multiple ideas are still alive, then we try them. We don't argue for hours and days.
Yeah.
We argue for a short time, and then we try.
There are many ways to do this. I would never say the way that we did it or the way that I would prefer to do it is the right way. There's no right way. There's 1,000 right ways. So, my suggestion is that when we see a different way of doing it, we actually try it. So I've seen this enough times that that developers talk about something, whether they should do it or not. When they could have tried it in 5 minutes, they talk about it for an hour. We could have just tried it, and then we'd have something real to look at. And that's what I prefer. So even in my own coding, and I try to code daily. I've been working on, just a kata that I invented for myself that requires that we analyze, so to speak, a crypt, something that's been encrypted. And I haven't analyzed it at all. I just say, well, what's the first thing this needs to do? This is sort of, to me, the approach of test-driven development. Well, what is something this needs to do? Let's make a test that proves that if we had this, it would do it. And of course, that's going to fail because we don't have it yet. And then we do it. And this is the approach I like to take. And this is very closely related to test-driven development. So I wouldn't argue that we should try necessarily every single idea, but that's what we did. So if 5 ideas came forward out of 5 people on the team, we probably would have tried all 5 ideas. Now, along the way, maybe the first one we try, someone will go, oh, wait, that's better than my idea. Let's just use that. So we don't need to try both ideas. But something that often happens when we try more than one idea is we come up with an even better idea.
Can I react to that, Pablo? I know you want to ask the next question, but let's hopefully have the discussion flowing. Again, I'm only experienced with pairing. I'm going to state that again.
Sure. The same stuff goes for pairing. Goes for pairing or for a team. Yeah.
Even in pairing, it's a social interaction. So sometimes ideas are worth something, but the people and the relationship they have is also extremely influential. Very pragmatically, what I mean is that I believe the strongest, I don't know the term, bear with me, English is not my native language, but one of the 2 person is the most influential and has to reinforce the other one to actually take the place, because naturally in their relationship, one of them takes more place. So the person who takes more place has to really actively give more space to the other person. Now, this, again, I don't know, but I imagine that if you have a full team, 5, 6, 7 people, it gets even worse because group dynamics are very, very important. So I can imagine that in my team, typically, a few person who stay silent would never share any ideas unless they are really incentivized, like someone asks them actively. So is that also something that is required? Because if you say we're going to try every idea, you're going to try every idea that has been expressed, which might not be every idea. And also some people might be very convincing. So you just said right now that someone might say, oh, okay, no, your idea was better than mine. It might be because the idea was better. It might be because of the group dynamics.
There is so much that's hidden. We never know what's going on inside someone else's head. So there's so much that's hidden that we can't control. But this really comes down to at least 2 things. And one of those is the idea of team flow that was written about by Jeff Van de Hout, who wrote a paper, did research on something he calls team flow. And there's a set of principles, or I should say prerequisites, and a set of characteristics that he shares. If we have the prerequisites are things like we have to have a common ambition. We have to have a common goal. These are 2 separate things. We're going to have a high skills integration. To have a really effective team, we're not a team of 6 people or 5 people with the exact same skills. We're going to have a variety of skills, and our skills are going to spread out across everything we're doing so that everybody has some of the skills in each area of the work we're doing, but we also have, some of us will have specialties or will be better at some things, expertise in some things and not in others. Other things include we have to have open communication. And we have to have psychological safety to have that communication. And if we use that thinking about psychological safety, there are different levels of psychological safety. There was a book written called The 4 Stages of Psychological Safety by a guy named Tim Clark. The first book that I ever read on teaming, which is where I've eventually got my name for what we're doing, came from the book called Teaming from Amy Edmondson. Nobody out there can see I'm holding up a book right now. I turned right around to a bookshelf that's behind me that could easily have just been a green screen of a bookshelf, but it's an actual bookshelf. So I keep most of my materials either nearby in hard copy or somewhere on my phone or computer. So the idea of psychological safety from the 4 stages that Tim Clark talks about. Before we have any kind of safety at all, we have exclusion. You're not part of our team. So we're not going to get any there's not going to be any psychological safety there. But we start with inclusion. You're part of our team. You belong here. Then the 3 more levels are, it's safe to learn here. You can grow, you can learn, you can question things, you can fail. It's all accepted. The next level is contributor safety. I can contribute things without fear. I can contribute things without being made fun of. My ideas will be accepted and used. The last level that he shares is called challenger safety. And this is where, we can challenge each other's ideas. We can safely challenge the status quo. We can challenge whatever the rules are. So these levels of psychological safety is what we attempt to have on the team. If we can build that, yes.
Interesting, because it relates to something I read. I do not remember who wrote it. So like psychological safety is a term that is mostly used by people who means different things. So they propose very simple test, 3 questions to kind of define what is psychological safety. And it's 3 questions. And the question is like, how often does it happen that people say, I don't know, I disagree, and I need help? And it was not like how easy it is to say that, is really how often does it happen? Because it might be easy for some, not easy for others. But those things naturally should happen. So if they happen like not often, or if some of them happen but not others, then you don't have full psychological safety. And it's quite interesting because typically in my current team, there's not many I disagree. People are very nice to each other. There's a lot of good ideas. And I realized that it might be a problem because probably people should be disagreeing from times to times.
Yeah. So if our work is of the nature that we're never disagreeing, it's probably very simple work. There are such things as groupthink and other dysfunctions that can happen in a group. And that will be that I no longer contribute. This is why we tried everybody's ideas. Because as soon as somebody says, well, I don't think that will work, there's a lot hidden in that statement. And that's one of the things we would attempt to never do, to say, oh, I don't think that'll work. The first issue is we may not understand the idea as it's being shared, and we won't understand it until we actually try to put it into code. We think we understand it. I've actually seen this many a time where a more senior person says, oh, what you're saying there won't work. We tried that last year, or we did that a few months ago, and we've already moved past that, whatever it is. But, my suggestion is let's go ahead and take a look at this. And then once we start doing it, go, oh, wait, that's not what I thought you were talking about. It's not until we actually start trying to implement it that we realize it's not what I thought it was. Because what we do as people is we jump to the end. We jump to the conclusion of what somebody's sharing or saying or intending without actually understanding it. And we do that
and
because
you're trying
it's
that
really
together, right? You're still talking about teaming, so actually share like a single person currently writing and everybody else participating in the discussion.
Yeah, so the way that we actually did this work was that if somebody had an idea they wanted to try, they would not be at the keyboard. Someone else would take the keyboard. The person at the keyboard then just tries to do as the person asks and not contribute and not change things. So they act as a smart input device, which is very hard to get. So we needed to practice that. We needed to get good at that. Because otherwise, that blocks the progress of the person doing the thinking. The person doing the thinking, and they hopefully are at the whiteboard, are going to be supported by everybody else on the team. And if our ideas are constantly getting blocked by somebody who's at the keyboard saying something like, I don't think that's going to work, or don't you think we should do this instead? We are blocking the use of the computer itself. The person at the keyboard acts as a smart input operator, or smart input device, if we want to think of it that way, who's getting the idea into the computer because they're good enough at whatever it is. Well, there's 3 levels of intent. The highest level is, here's what I want to try. The second level is, here's where it's going to be in the code. And the third level is, here's the details of how it will be done. So we try to never program out loud. We would never say, write public void, get the customer. You would say, we need to be able to create a new customer. And if the person at the keyboard doesn't know how to do that, we might need to guide them down to code level instructions. But most of the time we don't. But the people who need that code level instruction, in a few weeks, they will no longer need code level instruction. They will be getting the skills they need to do the things that we're doing.
It's funny that you're mentioning that, because it feels like with the new hype of vibe coding and AI stuff like that, the skill of actually explaining what you want while not explaining how to code it, which I believe is a very important skill, like explaining your ideas, but not down to the last character, is getting trained more and more. Like
Yes.
in the past, I've met a lot of people who struggled explaining their ideas. So they would typically feel a lot of emotional impulse to write the code.
That's right.
It's a little bit like when you're looking at your grandma scrolling a web page and just clicking on the scroll bar, like not even using the wheel, you feel something very emotional, like I'm gonna do it for you.
Right.
But we have to go through that skill of explaining your ideas. That there's value in that. So it's very funny that you mentioned that, because I believe that getting that skill of explaining your values is now getting trained a lot.
Yeah, and that's something we would have learned in pair programming, 25 years ago. That this is the way pair programming, in my experience, works well, is when we're expressing ideas, not code.
And in the end, it's also divorcing the team from the actual implementation, right? Like, as long as you're discussing ideas and the actual implementation matters less, of course, you still have 4 or 6 pairs of eyes looking at the code, so you will spot bugs and stuff like that. It makes so that the actual implementation is less important than the idea you're trying to implement. So if you are sorting an array and you use map instead of for each, it's fine, as long as the greater idea is respected, right?
Yeah, and everybody has heard the idea. I think this is like a big value. At least it was in pair programming. In pair programming, big value is there's at least one other person who knows the reason why the code is written the way it is written. I guess big value of teaming is that everybody will have access to why, what was the purpose. So it means that eventually there's going to be a bug in that code. It happens, but everybody will be aligned about why was the code written in the first place.
So this has to do with sharing the cognitive space and the context of the work we're doing. If I'm working solo and I've completed my work, and then someone someone else is working on it later, they might ask, well, why did you do it this way? Because we could have done it that way. Well, of course, being a programmer for a long time, there are 1,000 right ways to do anything. So we kind of get stuck on that side of things, but we don't need to. But the point is, how do these things relate with each other? Like when I first learned object-oriented programming, which I like quite a bit, it was a challenge to understand it. But the idea was we're decoupling things. It has a lot more to do with how we interact with it than how it does what it's doing inside of itself. So this is a separation of concerns and things like that. Because that was a long time ago. But you get the picture here. It's like, we don't necessarily, the implementation isn't nearly as important as how does it accomplish the thing we're trying to accomplish. I have been experimenting quite a bit with AI-generated code, and I do see a lot of issues with this, and maybe there are some people finding really effective ways and things to do with it, and I've seen some good examples. But my own experience so far is that we need to get really good at training the system that we're using to work well. And that's sort of what we did as a team. So we're, in a way, since the beginnings of pair programming for myself, but also working with a team, which goes back to a paper that I read in 2001 or 2. There was a paper in a book called Extreme Programming Perspectives. And in that paper, they wrote about what they called mob programming. And they were experimenting with 3 or 4 or 5 people at a single computer. A couple people, I think, who worked at ThoughtWorks. And they wrote a paper about it that was, I think, submitted, and maybe a talk was done on it at one of the extreme programming conferences way back in the early days. I was already introduced to pair programming. And as soon as I heard the idea you can have more than two people, I thought, okay, that makes sense. How does that work? So I started experimenting with it. Somewhere around 2005 or 6, I was working at a place where we were often paying attention to the problems that we were having. And there were a few of us out of maybe, 80 programmers who were talking about we need to refactor some of this code. And although I had some experience with refactoring, I wanted to get better. And Michael Feather's book, Working Effectively with Legacy Code, had just come out. And I had read it. As soon as I got it, I read it cover to cover. It doubled pretty much the techniques I was using for working with legacy code. And we started meeting every day at lunch for an hour, refactoring code together. And the way we would do it was one person would sit at the keyboard, and the others, there would be 5 or 6 of us, would be suggesting things. We would look at a chunk and say, hey, maybe let's extract out a method there. Let's make a seam in here where we can add some tests, and so on and so on. So I had already experimented with working with 3 people on a team by that time, and had a big success with that, rather than just a pair, so 3 people. So now we were doing 5 or 6 people.
Then what's the limit? I'm playing Pablo here. I should be asking the question, but I'm thinking, okay, if we are absurd, maybe there's something which is obviously too many. So 1,000 people, right? 1,000.
Well, no,
people.
That's for the team to decide. I would never say there's a limit. To me, that's inappropriate for me to even suggest. The team will figure out what they need, and we had a heuristic that we used. The heuristic was this: if we can answer all of our own questions, then we have all the skills and knowledge we need. If we cannot answer our own questions, we're missing a person or some skills that we need to have. So that was the beginning. If somebody's sitting there, they don't feel they're contributing, they don't feel they're learning anything, then maybe they're not needed on the team. So the team could self-adjust conceptually, could self-adjust on anything we're working on to what is the right team. But I would never suggest, there were the 2 first questions I ever got when I first shared this at a conference. I gave a very short talk, 20 minutes or a half-hour talk, because a lot of people were asking me about this. Well, what is this? And we got identified as being the people who are bringing this forward, but we didn't invent it, clearly. So anyways, the first 2 questions after I presented what we were doing was, what's the right number of people for a team? And the second question was, how can you possibly be productive with 5 people or 6 people at one computer? And because our picture showed there was 5 or 6 of us. And so the answer to the first question is, there is no right number of people. That's, like in Scrum, they would talk about, 7 people plus or minus 2. And I've seen these numbers over and over, and people talking about Dunbar's number and all of that. But I believe that the team will figure out for themselves what is the appropriate number. It's not something a manager should ever concern themselves with. It's something that people doing the work should concern themselves with.
It's funny that you're mentioning that, because I was just talking with Pablo about Scrum. Scrum does not say that, to be clear, but people say that because people want simple answers to complex questions. But okay, so the team decide its size, but you're really talking about the teaming session, if I might say. So let's imagine that we have some existing structure of a team. I don't know, maybe 10 people. I don't know. But every teaming session create like a temporary team of as many people as they would require. So it does not have to be all the people from the existing team teaming together. Maybe 4 of them will be teaming on something. Is that an acceptable structure?
It's up to the team to decide, what do they need? How is this going to work for them?
In my experience, when we tried it at Recover, the self-adjustment of the team was a bit more complicated because, as Woody said, there is always hidden things and hidden social interactions. And the fear of missing out factor was quite big. And so people were afraid of just saying, okay, I'm not going to be there today because I'm not needed and I'd rather do something else because what if when I come back I'm lost? Or things like that. But on the other hand, when we did not have the answers to our own questions, the first impulse of the team was, okay, let's get someone in here that can get the answers for us. And then, well, we're a small company, so people have other things to do and they would leave. But the first instinct was to get those skills or those answers to our questions, right? Like, because it's very visceral when all the team is working on a single thing that we're blocked. Because if I'm the only one blocked in a team, and we're just working in parallel and everyone is doing their thing, I'm blocked. It's up to me to find answers, right? If the whole team is blocked, is the very visceral reaction is, okay, how can we unblock this? How can we get the skills we need to move forward?
That's a very good point.
Okay, I have more questions about that topic. I think that trying to convince people to do pair sessions, it has multiple blocks, which would be even greater for teaming. So I'm typically thinking about these. First of all, you said like if the team does not have all answers, they should invite more people. I believe that very often people think they have all the answers, but they don't. So most of the time when I'm trying to convince people to do pair programming, we just try. I have to convince them just to give it a try. And then they realize that they knew less that they thought they knew. So how do you handle that in teaming? Second, you mentioned that people can leave if they don't believe they contribute to something. How do you handle the fact that they actually want to be programming? Being in the zone is very, it's a good reinforcement. It's something we want to feel, we want to live as programmers. It feels good. So I think there's a force pushing some people out of the team because they actually want to get their dose of rewards, of emotional rewards by actually building something. And the last is guilt. It's strange because it's at the exact opposite of the previous one, but I've met a lot of people feeling guilt when doing pair programming because they strongly believe they should not be doing that. They were wasting time, or some alternative way of working would have been better, so they felt guilt about that. Funny thing is they also felt guilt about a lot of different tasks, but like pairing was a lot, and I can imagine if we bring 5, 6, 10 people in the room, that feeling of guilt will be very, very present for a lot of them.
Yeah, so maybe we need to create this guilt-based programming concept and start promoting that. We need to find a way to turn that into a certification program that you can become a guilt-based programmer.
Isn't that hacking? If you're doing it illegally, you're bound to feel some guilt.
So let's start with this. First of all, if we don't understand flow, then we are going to feel uneasy when we're not creating as much code as possible or sitting at the keyboard doing as much coding as possible. If we believe that that's how we are productive, then we probably need to better understand what flow is and how flow works. Just as an example, one of the things we found as a team was that at the end of the day, we would kind of feel like we didn't get much done. But when we looked at our board, we were getting a great deal more done than we would have when this team was first working. When I first arrived there, they were always working solo. And so essentially the way a lot of companies work, whether they're doing Scrum or any other kind of thing, I'm not a fan of Scrum. I think Scrum actually, that was a thing for 20 years ago that people are still using, and thinking about Scrum is something that puzzles me. But, we moved way past that couple decades ago. But whatever people are doing, whether they're doing something more akin to a waterfall, they still have meetings. That's how we work together. We get together in a meeting. We talk about what we've done. We share the ideas of what we think we're going to need to do. We coordinate that work, and then we go off and work alone. So this is very common. But this introduces disruptions to flow. So the power of flow is that things will go smoothly. It won't feel as busy, but we'll be getting more done. Things are going to move through our system rather directly. So what we used to call mob programming, we're working on one thing at a time. So if we have something to get done, we say, okay, this is something we need to get done. And we're going to work on it from beginning to end. We're not going to be having a database person working on part of it, a front-end person working on part of it, back-end person working on part of it, a tester working on something when it's ready to test. It's not separated that way. All of a sudden, our work was getting done much quicker. When we started doing this, the very first few days, we started realizing, boy, we're getting a lot done. Matter of fact, the very first session we ever did this at the end of the day, and it was purely by accident that we worked this way that day. But at the end of the day, we were always reflecting at the end of the day, how did today go? What was good about today? And how can we get more of that tomorrow? And at the end of that day, we observed 4 things. We got a lot done. It was really high quality. It was really the meaningful stuff. And besides it being high quality, it was also better done. There's many sides to quality. It was less stressful. So at the end of the first day, we found it to be very useful for us. How are we going to turn up the good on it? Let's just do more of this tomorrow. And so the point I'm making is that over time, we didn't feel as pressured, as busy as we used to, but we were getting more done. And it was better done. It was higher quality.
I'm assuming it means that you didn't have to pay some effort which was wasted before. I'm assuming that's how the magic trick works. So what do you think was the waste?
This is flow. We were achieving flow. So flow in lean terms. So there's psychological flow, which we can think of as about being in the zone, and there's lean flow. There's other kinds of flow as well, but that have different meanings to the word, to the use of the word. So in lean flow, and we think about single piece flow, a piece in production, if we think about an assembly line, goes from start to finish without any queuing or waiting and without any excess inventory. Only sufficient inventory, purely done. If we're building a car and we need a door for the car, the door is made immediately before the door is needed to be put on the car. So the idea overall is we're not doing any excess inventory because inventory is waste. And in software development, you can think of it as being partly done work. Any work that has been done that isn't in the customer's hands is inventory, if we use lean terminology. So a good example of that would be a product owner sat down and started gathering some requirements. So if we have a product owner in our company, they've started gathering requirements for something we might have in our product later. That is inventory until the customer is using it. It can stop also being inventory when we say, no, we're not going to do that, and we cancel it. But any work that we've done that is still in our system, that hasn't moved on to being in the user's hands, is inventory, and that's waste. So we were eliminating the inventory, and we were eliminating the queuing. Queuing happens when work has to sit idle for any reason whatsoever. Queuing and delays, waiting are very closely related concepts. So this is what we discovered was happening. We didn't yet really know how to explain it, but in many decades earlier, in my 20s, I'd worked at a factory where they used lean principles in the 1970s. And I learned quite a bit from watching that. It didn't completely set in with me at that time. It wasn't until over about 10 years later that people started writing books about it. I can hold up dozens of books I have on this one from 1980. I've got books here from the mid-80s, early 90s, and so on the ideas of lean and before they were calling it lean. These were the ideas we were using. So let's go back to flow. If a piece of work can go from, oh, here's something we want in our software, to immediately let's create it, to let's deploy it, and it's in the customer's hands, that's when we've achieved flow. People started asking, remember the first 2 questions, what's the right number of people? And the second question, and I don't know which one really came first, but the second one is, how can you possibly be productive with 5 people at one computer? And at first I said exactly this, I don't know. Does that matter? I don't care how this is happening. All I care is that we've observed that this is what we were getting from it. But
today you think it's happening because you don't have to pay the inventory cost, basically. That's your main theory.
The queuing is the biggest waste. So according to Reinertsen, the principles of product development flow. So one chunk of this, one chapter in it is on queuing. Another chapter of it is on inventory, I believe. Those principles this book was written almost exactly at the time we started working as a team. And this other book that I showed earlier, and of course nobody can see it, Teaming, that was also written at almost exactly the same time. I was starting to have to figure out, how do I explain this stuff? at the same time.
And I think the team topologies book also
that came out a bit later.
Yeah, but it also mentioned flows.
Yeah, of course, they do, I'm sure, refer to Reinertsen and probably refer to Amy Edmondson, the authors of these two books. So Reinertsen, one of his principles of queuing is essentially that queuing is the primary cause or the root cause of the majority of waste in product development. And what we do in creating software is product development. So if queuing is the cause of the majority of waste, then we need to do something about it. Well, we didn't set out to do anything about that. We just automatically did something about that. As we investigated, what is this? Why does this work? The two are now really three big things where we were now paying attention to flow and we were getting single piece flow, except for when the person we needed to talk with or get an answer from wasn't on our team. And then we have to find them, and now we were waiting in a queue. And that started telling us the team is not just some developers. The team has to include all the skills and knowledge we need, which we found there were four main areas where we had problems. Testing, product expert, which you can think of in a lot of companies as a product owner or something like that, the database people, and the operations people. Well, since those days, things like DevOps came along and people are in charge of deploying their own stuff, and we start working towards that. We added a tester to our team, and we started guiding the team itself, was doing all of our own testing as we went. We eventually brought the product owners onto the team best we could, and there's a lot more. I have talks that I give on this, and you may have watched some of those. This is what we did. We brought all of this within the team. When all of that is in the team, so what's the right size for the team? It's if we can answer all of our own questions. The moment we have to stop things because we're blocked because we don't have an answer and we have to send someone an email and we may not hear back from them. Let's say we hear back from them in 10 minutes. Not a big deal, really. But they're not going to be in the same context as us, so it's going to be a lot of work getting them up to speed. But what if it takes an hour? What if it takes 2 hours? What if it takes a day? We were compressing our times to being only what they call the value-added work. You can use a value stream map to measure this. And that's something I learned to do from Mary Poppendick's book. She's got a very nice section here on value stream mapping. This is something I started using back in, the 2001 or 2 or 3. This book came out in 2003. We can measure this. We can actually measure the queuing. Now, the issue with queuing is as soon as we stop, we're blocked. What do? What most people do is, you can tell me, we're working on something, we're blocked, we sent an email, they haven't responded, we sent a couple calls, they're people, wherever we call, they say, oh yeah, they're in a meeting right now, they'll get back to you later. And then we get an email from them later saying, I can't look at this today, but I'll look at it tomorrow morning. We are in a queue, we are idle on that item. What do we usually do when we're idle on an item? We context switch. We move to something else. So this means we've introduced inventory, which to me, and probably Reinertsen, is the second biggest waste. The first biggest waste, in my opinion, is queuing, or the way I see things right now. And the second biggest is probably inventory. Inventory being anything we've worked on that's only partially done. So we are overloading ourselves cognitively when we do this. We have one thing we've been thinking about, and now we have to work on something else. Our brain doesn't stop thinking about that first thing. And we're wondering, well, should it be this? Should it be that? We start making assumptions. We've introduced inventory, so we've doubled our waste. We haven't solved for the waste. We solved for the wrong problem. So once we realized that, we started needing to expand our team. The first thing I did was I got the opportunity to hire someone and add to the team, and that was a tester. So we added a tester to the team. And everybody on the team now ups their skills on testing, and all of our stuff is tested within the period of time of us creating it. By the time we're done creating it, we have all the tests, automated tests and other kinds of tests in place. We can do any final testing we need and deploy the thing. So now we need to bring the deployment skills on because we had to give them to someone else and they need to schedule deploying it. You see, this is the thing. We achieve flow by having everyone stay in the same context. And this means no one person is working as hard as they used to work, but more stuff is getting done. We're not getting any of the blocking that we would have had. So the main waste of time, and I can show you any number of value stream maps that would show this, in software development is the waiting. The easiest one to look at is a bug fix. So somebody out in the field who's using our product recognizes a bug to say, oh, wait, this isn't working right. So the work starts right at that moment. They have to document it. Then they send it in a bug system or in an email to somebody. Somebody has to open that email. That bug is waiting to be worked on until somebody is actually working on it. Between when it was recognized and when somebody's working on it, we'll usually have not minutes, not hours, not days. It will have weeks. There will probably be a weekly triage meeting. So something's in a queue until that meeting. Then once it's in the meeting and they make a decision, they prioritize it. And now it has to bubble up to the top of the priority to have somebody get it on their list that they need to assign somebody to work on it. All of these things, if you do a value stream map, can be easily seen. That waste is humongous. That waste is huge. If we compressed all that waiting out, things would get done immediately, rapidly. Much more rapidly and almost immediately. That's what I meant to say. So this was what we had observed, and we needed to learn about this. We studied this stuff. We first talked about this in, I think, about July or August publicly of 2012. And right after that, we started getting invitations to speak at conferences. And we realized over and over again, they wanted to ask those two questions. What's the right number of people? And how can you possibly be productive with 5 people at one computer? And instead of saying, well, we don't know, we figured out we needed to know. That's why reading books like Reinertson's and the teaming book and the research by Van de Hout called Team Flow became important to us. I'm not trying to convince anybody they should do this. I'm just telling them why we think it worked for us. I don't really care what other people do, but I think everyone should have a chance to work in an environment that is really fulfilling. So you brought this up earlier. If we feel that we need to be at the keyboard because that's how we get work done, we just have to learn there are other ways we get the work done. Almost every day we would notice, boy, I didn't work very hard today, and I'm relaxed at the end of the day, as relaxed as when I started. I'm not worn out. But we could see from our Kanban, our board, that we got a lot done that day. More was getting done after we started working this way than before. So, and we just started scratching the surface here. Again, I'm not trying to convince you of anything. I think almost any objections somebody can have to working well as a team probably can be addressed. Because I think that overall, we need to interact with others, regardless of whether we want to or not, so we might as well get good at it. And if we get good at working with others, there'll be some huge benefits for us.
In my again limited experience with it, I think what would sum up a bit of what you both were saying is that the hero sense of progress was really slow. Like, you yourself feel like you're not working, and it does induce a bit of guilt of, they are paying me to work hard, quote unquote hard. I'm not doing what I'm supposed to. I'm a naughty boy. I shouldn't, blah, blah. But on the other hand, and we didn't have as much measuring, so this is more of a feeling that I have. But on the other hand, the feature that we worked as a software team, or the couple of features we did go out the door faster than they would have. In part because of that flow, we are separated backend and frontend. So you can imagine that we do a planning, we do some specification, then the backend will do its thing. Oh, the frontend, no, finally, the API should not look like this. Oh, I'll change it. Now I change it, now I return. Can you review this? Can you review that? Okay, now we will send it to product that, hey, can you test this? Oh, it's not exactly what we want. Okay. Oh, I mean, this other feature, etc., etc., etc. So all in all, the feature got worked on faster. And whilst we don't work as a team anymore because, well, we don't do software teaming anymore. We do still try to work as a team because of different reasons, but partly working as a team does imply some difficulties because there is a steep learning curve to arrive to that point where people can express themselves, etc. Without it being exhausting. There was a big lesson that we learned from that, and it's what Woody is describing as flow. And now we have one main priority that must keep moving at all times. And that's the imperative we took from that. And if that is done better as a team or as a pair, let's do it as a team, as a pair. If the person feels it's better done individually, let's do it individually.
I would like to ask, have you used a value stream map to measure the idle time for that work?
No, we have not.
Because I've seen, so even in the in Mary Poppendieck's and Mary and Tom Poppendieck's book, the Lean Software Development book that I mentioned, they show a couple examples of value stream maps that are sort of at the project level. So we might have a period, let's say, of development. Let's just give a number of 1 week of something. But during that 1 week, that work is not actively being worked on during that whole week. Any particular work item can be put into have a value stream map created for it. And we will see many things are sitting idle during that period. And we believe, a lot of times, managers believe, and the way the work is managed shows they believe this, is that's okay. That as long as there's something being worked on at every moment, everybody's as active as can be, then we're okay. But we're not. This is the utilization trap. The utilization trap is we want to keep people as busy as possible. And then we think we're getting the most value that we can get. But it's almost the exact opposite. So there is this concept of collapse because of utilization. And this is another thing, you can find principles of it in Reinertsen, but it's been around for a long time. There's the common example of a freeway that is being fully utilized. That means you have cars in every space on the freeway. Well, what is that? That's a parking lot. A freeway that's fully utilized, the cars are not moving at all. So what they've learned in traffic flow is that you limit the number of cars on the freeway, and then everybody will get to where they're going faster. They'll get there more directly.
It feels related to the cost of delay as well.
Oh, it's exactly the cost of delay. That's exactly right.
It's a bit unnatural, but we always believe that the most we release, the highest the value, but it's less intuitive to think that the latest we release, the least the value. So actually delivering sooner, I'm going to use it the other way. Delivering later has a very much reduced value. That's the cost of delay. So what you're saying is basically when we team, we release earlier, which reduce the cost of delay and also has a lot of additional benefits. But I was thinking, when we were talking, I was thinking to myself, why is queuing such an important problem? Because it feels like queuing properly in a system, that's how you optimize for throughput. When you do smart queuing, you can have the optimum throughput. But basically, if you consider the cost of delay, it means that throughput is not a good indicator of value because of the cost of delay. So if you have optimum usage, that's what you said, usability, you just said, the concept you just mentioned, if you use your freeway as much as possible, you actually do not optimize for value.
So that's utilization. And so the issue with utilization is you'll get collapse of a system nears collapse at some certain percent of usage. And when you achieve that, when you get to that point, then you will have all of a sudden, there will be no service. So you can see this so this is one of the problems of a lot of people paying attention to things like cycle time, which is very much a lagging indicator. But to refer back to cost of delay came into the software world through Reinertsen's work, as far as I know. Prior to Reinertsen, there were people writing about it and sharing stuff about it, but I think that it is covered pretty much in the principles of product development flow. Knowing what the cost of delay is can be very much problematic. That's difficult to know. But the utilization trap is pretty much that as managers, we think we need to have everybody as busy as possible. So one way to think of it is we have features, valuable features that we want to deliver. And we have valuable workers that we want to utilize. So the problem comes in is when we optimize for the workers instead of for the features, for the work that we want to have getting done. When we optimize for keeping everybody as busy as possible, things will actually get done much slower, but it feels to us like we're getting more done. A really good typical example I've seen on a team is you might have a team of programmers who are mostly working solo. They have a couple tech leads or maybe a tech lead. Everybody comes to the tech lead with their issues. They go, I'm not sure how to do this, or how is this going to fit in? What are the things I'm not getting with this, and so on. So the tech lead becomes overburdened often helping these other people, and they still have their work to get done. So they start saying, well, let's have a meeting every Tuesday and Thursday, and then just save up your questions and ask me your questions. So this system of utilization is making it clear that we are going to be as ineffective as possible because we're putting everybody into queues. So we're building inventory and we're increasing the waiting or the queuing. So this is the issues that we have. The utilization trap is we think we need to keep everybody busy. What's more important is to keep the work flowing. What we don't want to keep the things we want getting done waiting for people to work on it. But that's what every system has. And Reinertsen and others will talk about this as being, related to batch size. So we need to get good at breaking things down and delivering them rapidly. That's my opinion. Not necessarily a reality, but that's what I think. If we get good at taking something we need to get done and just decoupling it sufficiently, making it small enough that we can do it directly from start to finish. And that's not a matter of estimating, can we get it done? It's just that if we can't break it apart any further, we now have something we can work on. And we can get that done and deployed and somebody actually using it. And the way that happened for us when we originally started working this way is a lot of work started getting completed and delivered within, a few hours that used to take several weeks or more to get done. And again, as we researched this is the things we found. Is that we got rid of the queuing, we got rid of the inventory, we started bringing the team, growing the team so we could get rid of more queuing and more inventory till we got it at least I was only there for 4 years, the best we could during that time. Now at that company, I left there in 2015. They're still working this way, and they've got a podcast or a video cast that they make on this they call Mob Mentality, that Chris Lucian and Austin Chadwick do, interviewing people just like this, who are working this way all over the world. So, I'm not saying this is necessarily the only way to work, but I think there's a lot of reasons. This is the foundation of it. Every bit of work we do requires we interact with someone else. We might think, well, we got this bit we can do alone, but that required we did a lot of interacting with others, and we've introduced a lot of waste into that. So let's get good. If we need to interact with others, let's get good at having great interactions. And what is that going to take? And for us, the form it took eventually was what we used to call mob programming, and I now call software teaming, but it's the same idea.
I'm gonna regrettably have to hang myself from that let's have great interactions thing you said. And sadly, although this was a great interaction, and it truly was, time is running out from us. And so I'd like to first thank you both from being here. It was really interesting. And secondly, ask you one last question for the road. And I guess it's mostly aimed to Woody. I will ask another version of the question to Philippe. Woody, if someone wanted to start looking into software teaming, where should they look?
Well, yeah, so it's really easy to find a few intros to this that I've had recorded when I first started talking about this from different conferences you can find on YouTube. So that's a beginning spot. I also wrote a book where I tried to capture everything I was thinking at the time that I wanted to teach in my workshops. So I wrote a book. It's available from Amazon, self-published there. So you can get it in Kindle or in a paper form. And one other thing is that I think that we just need to understand that we need to get good at the interactions. So whatever form that takes. I really believe working as a team, I've got good examples to share. Whatever that takes, we need to learn to do that. So if we're saying, it's too hard to learn to do this, it's taking time, that means we're falling into the capability trap, which is we're so busy trying to get our work done, we don't have time to improve. And we were taking time to improve. So if you want to start it without any other introduction, I would say just gather 2 or 3 people in a room, pick some bug fix that you need to do with the intention that we're going to throw away the code when we're done and we'll redo it afterwards. Just sit together, interact with each other, be nice to each other, listen to every idea and try every idea. And you can get there. That's all, I had been doing. There's no, this is the right way to do it.
Cool. Thank you very much. And the modified version for Philippe is, Will you try software teaming in the near future?
I cannot guess the future. It sounds interesting. I want to. First, I want to better understand because there's a little bit of convincing as for any change, basically. So I want to be able to be convincing first, and to be convincing. My way to incorporate anything is to understand. That's how I like to work. This is why I want to know more about this queuing and utilization trap, and because if I understand what do we currently waste, because it has to be a magic trick. Like if we gain something, it means we are currently wasting something. So this is what I want to better understand. And overall, I think there's a global team concept, which is a bit difficult for many reasons, but you mentioned one of them. There's the hero, there's the like psychological flow. We like what we do, the way we do it. So I think I'm gonna probably introduce a larger push to thinking as a team, a bit less of individual. I'm very lucky because my team is already like thinking that way, but they're lacking ways to do that, and I don't want them to lose the benefits of what they currently have. So it means if I'm swapping something for something else, they still have to feel good. I'm gonna use that word. But yeah, it definitely sounds interesting. I like the way you proposed with the bug fixes. I think it's an interesting way. I also have a few people in my team who are already doing some of it. I'm typically thinking of a full stack engineer who likes to do session with a designer, and they realized by themselves how useful it was. And it's not really pair programming because they have very different skills. So it looks more like what Woody explained. Even though there's only two of them, I would consider them as a team and not as a pair because of that skill difference. And if they're convinced, they will be convincing. And then again, I can bring more people. I have some additional challenges in my team, people working with the different time zones, people working with different schedules. So probably I can just keep those for the end, convince as many people as I can initially, see if it works, because Woody mentioned it very often. The team decides. So the team will decide. Pablo, you mentioned it that your team has tried and has decided to go in a slightly different way. So I don't decide for my team. I'm presenting them ideas that hopefully will improve the way they work.
Well, it only remains to thank you again both very much for being here. It was really interesting to hear you both discuss software teaming. Thank you very much.
My pleasure.
Thank you.